Okay. So, again, pages 23 and 24 of your composition book, you can title that, just like on the board right here, Solving One-Step Inequalities. Then if you'll turn to page 23 in your composition book. And you can title it 3-2 and 3-3, which again is solving one-step inequalities. So both of these sections focus on solving one-step inequalities. The reason why we're doing them in both in one day is because 3-2 simply focuses on addition and subtraction, and 3-3 simply focuses on multiplication and division. So it's pretty easy to group those all into one. These should be a pretty easy section for you because we just got finished learning about solving equations. Solving one-step equations. Solving one-step equations and solving one-step inequalities is almost the exact same. The process to solving them is pretty much the same. For example, if you have s plus 1 is less than or equal to 10, you're going to solve this in the exact same way you would if it said s plus 1 equals 10. The difference just comes in your solutions. To solve for s, what would you do? Good. Take away 1 from both sides. So your solution is that s is less than or equal to 9. Now it's important for you to understand, even though solving that was the same, that is not the same as s equals 9. What's the difference between s equals 9 and s is less than or equal to 9? Exactly. S can be a variety of numbers as long as the number is less than or equal to 9. So what are some numbers that S could be equal to in this example? 9. 8.
7.
6.
5.
Okay.
4. 3. 2. 1.
Is there any way we could sit here and list all of the numbers S could be equal to?
No.
No, because there's also fractional numbers in between each one of the whole numbers, which is why it's so important for us to show the graph of the possible solutions. This is why we graph inequalities, because there's no way we're going to sit here and list every single possible value of S. But we can show it fairly easily on a line graph. So remember, on your line graph, you just need 3 points. What sort of circle should I put on 9? Closed. And then if you have a highlighter, you can use it to show that your arrow should point which way. Left. So this now shows that S includes all the numbers that are less than or equal to 9. Now, just like you hopefully did on your test last Friday, you can still check these answers fairly easily. All you'd have to do is pick a solution of S, plug it back into the original equation, and solve to make sure it's true. We'll show an example of that in just a minute. Okay, here's another example. 2.5 is greater than -3 plus t. So what would I do to solve for t in this example?
Add 3.
2.5 plus 3 is? Good. Now be careful with this type of problem. The only difference between this problem and the one that we just did is that now the variable is on the right-hand side of my inequality. Okay? That just makes a difference in how you read the answer. You always want to read your answer in terms of the variable, not in terms of the number. So this says t is what? less than 5.5. Okay? T is less than 5.5. So if I wanted to flip these around, it's important that you have to flip everything. You can't just switch the spots of the T and the 5.5. If I'm going to put T over here and 5.5 over here, you have to switch the sign as well, so that this still says T is less than 5.5. The only reason it might be beneficial to always put the variable on the left is so that when you're graphing, your arrow for your graph goes the same way your arrow for your inequality sign does. So I would put 4, 5, and 6 on here, and then 5.5 would go in between 5 and 6, and my arrow needs to point to the left.
If you don't have a highlighter on the test, how do you show it?
Just like a darker line.
Okay.
But I'll let you guys use highlighters on the test.
Are we checking your work?
Not today. Okay, so section 3-2, like I said, only deals with addition and subtraction, like these two problems that we just did right here. In 3-3, you'll see multiplication and division. For example, 2k is greater than 24. 2k is greater than 24. So how would we solve for k in this example? Good. So k is greater than 12. So my graph would include what kind of circle at 12?
Column.
And my arrow should point to the right. So what are some possible values of k in this example? 13, 14, 15.
16, 17, 18, 19.
1,664,000.
Okay.
No, 72.
What about 12?
No.
No, it cannot be 12.
No, it can't be 12 because 12 is not greater than 12. Right. It has to be greater than 12. Could it be 12.1?
Yes.
Yes. But it can't be 12 because, and that's what this open circle symbolizes, is that this number is not included in the solution. Okay, how about this one? Negative 50 is less than or equal to 5 cubed.
Divide by 5.
Okay, divide by 5.
Thanks, guys. Negative 10 is less than 9. Wait, what?
Now remember, always read your answer in terms of the variable. So I would not read this negative 10 is less than or equal to q, because I want to know what q is. Q is
Less than or equal to 10. It's
Greater than or equal to.
q is greater than or equal to 10. So if I wanted to rewrite this, I would need to rewrite it like this.
Flip it.
You don't have to rewrite it. It just might make it easier to graph. But this is a perfectly acceptable answer as well. It just, if you write it like this, then your arrow on your graph is going the same direction.
You have to put the side on the other.
Oh, so the variable is first.
Yeah.
That's so easy.
Okay. Before we move on, I want to look at this example. If I have the inequality 3 is less than 7, would everyone agree that 3 is less than 7 is true?
Yes.
Okay.
Yeah.
Now, in the past, we've learned that if you multiply or divide both sides by the same thing, the equation or inequality stays equivalent, right? Just like we did here. When we divided by 5 on both sides, this inequality stayed true, right? Because
Yes.
whatever we did on this side, we did on this side. Okay, So if you were going to do that here, for example, if I were to multiply both sides by the same number, do you think that the inequality would stay true?
Yes.
Okay, so let's try it. If we multiply both sides by -1, -1 times 3 is what? -7 times, or sorry, 7 times -1.
And that would not be true.
So,
It is.
since we multiplied by -1, is -3 still less than -7?
No.
So, this demonstrates why when you multiply or divide by a negative number, what do you have to do the sign?
Flip the sign.
Flip the sign, yes. So I want you to write that. When you multiply or divide by a negative number, flip the inequality sign. This is so important, and I guarantee this is going to be the biggest mistake on the next quiz or test, simply because it's so easy to forget. Anytime you divide or multiply by a negative number, you need to flip your inequality sign.
With the inequality sign or just the like sign of the number?
The inequality sign. So this really should say -3 is greater than -7.
Oh.
Because since we multiplied by a negative number, we have to flip the inequality sign. So instead of less than, it flips to greater than.
Then why are we multiplying it by negative?
That was just a demonstration. If you had to, in an equation, to solve for it.
Oh.
So go on to the next page if you need to, and let's do this example. -9a is greater than 81. So in this example, in order to solve for a, what do I need to do to both sides? As soon as you realize that you're multiplying or dividing by a negative number, what I would recommend you do, I like to circle the inequality sign and go ahead and flip it. Because if I wait until the end, I'm going to forget. That's the first thing you should do before you start dividing either side. Flip the inequality sign. Now we know -9 divided by -9 cancels out. And what's 81 divided by -9?
-9.
So a is less than -9.
It could be -10.
Wait, Robin, 81.
Because 81 divided by -9 is not 81. Now, to check this, which you should be doing, especially on a quiz or a test, what could I do to make sure I did this correctly? Could I put -9 in?
Or you could just do -10.
Is -9 part of this answer?
-10.
Oh, no.
No. So I can't put -9 in. I could put -10 in. -9 times -10 should be greater than 81. See how I went back to the original problem? -9 times -10 is what?
90.
So is 90 greater than 81?
It is.
Yes.
So it's true.
So I know I did it correctly.
If you divide by negative numbers, then you have to flip the sign. Else it won't be true.
Okay. How about this one? Y divided by -4 is greater than -1/2. So Alex, what would I do to both sides in this example?
You would multiply 10 negative.
As soon as you multiply both sides by a negative number, switch your sign.
The top divide by -4. Oh, y.
Yeah, Y, sorry.
That would be 2. Y. 2.
Negative
No,
times a
it's
negative
Definitely
is a
Oh, it's negative 1/2? Ooh.
Go ahead and graph your solutions. And let's check our answer. So Grayson, what could I plug in for y to check my answer?
You know.
Grayson.
Sorry.
Okay. So 1 divided by negative 4 is greater than negative 1/2. So that basically says negative 1/4 is greater than negative 1/2. Is that true? Mm-hmm. So we know we did it correctly. Okay. I want you to close your composition books. We're going to have a little bit of time to get started on the homework because it's 2 pages since it's 2 different sections. So hopefully you can get some of it done during class.